Hello friends, welcome back to my YouTube channel. In this video, I'll be talking about high pressure vessels. It would be an introduction to high pressure vessels. And in my coming few videos, I will be discussing design of high pressure vessels. So in this first video on high pressure vessels, I'll be talking about, I'll be introducing high pressure vessels to you. So let us begin the discussion. Now, before we go and understand what are high pressure vessels, let us first know about the limitations of Indian Standard 2825 1969. So let me tell you, this is a standard that is being followed for designing unfired thin-walled pressure vessels in India. This is an Indian standard. So this cannot be used for designing high pressure vessels. There are certain limitations. Every other country will have its own standard for designing pressure vessels. I am talking about the Indian standard 2825 1969 and why it cannot be used for designing high pressure vessels. It is concerned with design of unfired thin-walled pressure vessels. So the Indian standard 2825 1969, it covers the design of thin-walled pressure vessels. It covers the design of vessels which are subjected to pressures less than 200 kg per centimeter square or 20 meganewton per meter square or 200 bar. So you can follow this standard for designing thin-walled pressure vessels that are subjected to pressures less than this values, 200 kg per centimeter square or 20 meganewton per meter square or 200 bar. It covers the design of vessels for which the ratio of outer diameter to inner diameter is less than equal to 1.5. It covers design of those pressure vessels whose outer to inner diameter ratio is less than equal to 1.5. So here DO is the outer diameter and DI is the inner diameter of the vessel. Or you can say it covers the design of vessels for which TS upon DO, where TS is thickness of the vessel and DO is outer diameter, as you know, this ratio is less than equal to 0.1. And this ratio is called the thickness ratio. In this case, TS is the thickness of the vessel or wall thickness for the vessel. Okay, so over here we have understood what are the limitations of the Indian standard 2825 1969. It is concerned with design of unfired pressure vessels. It is concerned with design of thin-walled pressure vessels. It is concerned with design of pressure vessels and that are subjected to pressures less than 200 kg per centimeter square or 20 meganewton per meter square or 200 bar. It covers the design of vessels for which the ratio of outer to inner diameter is less than equal to 1.5. And it covers the design of vessels for which the thickness ratio of thickness, wall thickness to the diameter, outer diameter of the vessel is less than equal to 0.1. This is called the thickness ratio. Yes, but there are many chemical processes where the process vessels or many chemical processes uses process vessels that are subjected to pressures that are greater than these values, greater than 200 kg per centimeter square or greater than 20 meganewton per meter square or greater than 200 bar. Some examples of such processes to tell you that such processes really exist. For example, Haber-Bosch process for ammonia production. It uses a pressure vessel in which the operating pressure is lying within this range, 10 meganewton square and 100 meganewton per meter square. The operating pressure lies between 10 meganewton per meter square and 100 meganewton per meter square. So Haber-Bosch process, which is used for ammonia production, it uses a pressure vessel that is subjected to operating pressures between 10 meganewton per meter square and 100 meganewton per meter square. So you cannot use the Indian standard IS 2825-1969 for designing this pressure vessel. We have to think a different way of designing such a pressure vessel. Then you have polyethylene production process, which uses a process vessel or pressure vessel where the operating pressure is 150 meganewton per meter square. Again, here you cannot use the Indian standard 2825-1969. All these are high pressure vessels, and we are going to learn how to design such high pressure vessels in our discussion. So therefore, there is a need for the design of high pressure vessels. That means there are chemical processes which uses process vessels or pressure vessels that are subjected to high pressures, and therefore there is need. We as chemical engineers should know how to design high pressure vessels. Okay. Now, the code IS 2825-1969, it does not cover the design of high pressure vessels. As I said, high pressure vessels are designed as thick walled vessels, whereas IS 2825-1969, it is concerned with thin walled vessels. Thick walled pressure vessels, for them, the diameter ratio of outer diameter to inner diameter is greater than 1.5, and the thickness ratio is greater than equal to 0.1. It should be greater than equal to 0.1. The thickness ratio is greater than or equal to 0.1. Okay. Stresses in such high pressure vessels, that is thick walled pressure vessels, stresses are induced in the vessel wall. And why these stresses are induced? The stresses are induced to oppose the pressure effects. Since these are subjected to high pressures, to oppose the pressure effects, stresses are induced in the wall of these vessels. Therefore, these being thick walled pressure vessels, a considerable variation occurs in these stresses with the vessel wall thickness. That means as you move from inner diameter to outer diameter for these vessels, there is a considerable variation in the stresses. Why stresses are induced? Stresses are induced due to the pressure effects or under the influence of high pressure to which these vessels are subjected. Okay, so the first thing is what the Indian standard 2825-1969 cannot be used to design high pressure vessels. It does not cover the design procedure of high pressure vessels. High pressure vessels, they will be designed or they are designed as thick walled vessels. And for thick walled vessels, the ratio of outer diameter to inner diameter is greater than 1.5, and the thickness ratio of wall thickness to the outer diameter, it is greater than 0.1. Okay. So in this, under the influence of pressure, under the influence of high pressure, stresses are induced in the vessel walls, and there is a considerable variation of this stresses along the vessel wall thickness. Okay. So now the induced stresses, the stresses that gets induced in the vessel wall due to the pressure effects, that has three components. So each component is perpendicular to the other. There are three components, and each of the three components is perpendicular to the other two components. So one component, which are these three components? One component each in axial or longitudinal direction. So one in axial or longitudinal direction, one in radial direction, and the third component is in the tangential or circumferential direction. Okay. So the stress that gets induced due to pressure effect, it has three components. And this three, what can you say about these three components? Each component is perpendicular to the other two. What are these components? So one component in the axial or longitudinal direction, one component in the radial direction, one component in the tangential or circumferential direction. Therefore, accordingly, there are three types of stresses. So you have axial or longitudinal stress, then you have radial stress, and the third one is tangential or circumferential stress. That means in the case of high pressure vessels, that is in the case of thick walled pressure vessels, three types of stresses are to be considered. One in the axial direction or the longitudinal direction, it is axial or longitudinal stress. The second one is radial stress, and the third one is tangential or the circumferential stress. So axial or longitudinal stress, let us denote it as sigma E. Radial stress, let us denote it as sigma R. And tangential or circumferential stress, let us denote it as sigma C. Okay, so if you have to understand this, let us consider this thick-walled cylindrical shell. So this will be the axial direction, this will be the radial direction, and this will be the tangential or circumferential direction. And as we understood, in each of these three directions, you have one component of the stress. So in axial direction, you have axial or longitudinal stress, that is sigma A. In radial direction, you have sigma R, that is radial stress. And in the tangential direction, you have tangential or circumferential stress, which we are going to denote by sigma C. Okay, so with this, I end my this small discussion on the introduction to high pressure vessels. So at the end of this discussion, you must have understood that you cannot use the Indian standard 2825 1969 for designing high pressure vessels, because that standard is applicable for designing thin wall pressure vessels, that is concerned with design of unfired pressure vessels. And this standard is followed in India. Okay, so for high pressure vessels, we have to design them as thick wall pressure vessels. And this being thick wall pressure vessels, the stresses induced in the wall due to pressure effect, they show considerable variation along the thickness. In fact, you have three components, three stresses involved in this case. One in the axial direction, which is the axial or longitudinal stress. The other one is radial stress in the radial direction. And the third one is tangential stress in the tangential or circumferential direction. Okay, so with this, I end my discussion video. Thanks for watching my video. Do subscribe to my YouTube channel. Please tell your friends to subscribe to it and hit the bell icon so that you'll be notified as soon as I upload any new video on my channel. In coming videos on this topic, we will learn how to design high pressure vessels. Thank you. Have a nice day.